Welcome! Today we're going to be graphing sine and cosine functions with phase shifts. All right, so I already have my grid here, so I can adjust I can write in my base values, my key points, and adjust my x and y values. So my key points occur at 0, pi halves, pi, 3 pi halves, and 2 pi. And the corresponding y values for cosine are also shown in the graph. Those are consistent for cosine. So now we're going to see if we need to change our x values if we have a period change or phase shift, or change our y values if we have an amplitude or a reflection or a vertical shift. All right, so I will tell you in this particular graph there is no vertical shift. All right, so let's begin and take a look and see if we have a period change. Let's see if y is going to change, or x is going to change at all. All right, so we identify, first thing we should do is identify b. So b is the coefficient in front of x, and b is 1. So since b is 1, there is no period change, and the period is 2 pi, okay, just like we always have. So I actually don't need that column because I don't have any changes due to a period change. All right, so we do have a phase shift. Okay. If we look here, we have our phase shift. It's what's added to x there in the parentheses. So our phase shift is a positive pi 6. It's pi 6 to the right. If we see a negative, we know we move to the right. If we see a plus, it means we had minus a negative, and we move to the left. All right, so we're going to take our phase shift and add it to all of our x values here. All right, so we're going to add pi 6 to all of our x values to get our new x values. So we have plus pi 6. 0 plus pi 6 gives us pi 6. Pi halves plus pi 6. Pi halves is the same as 3 pi 6. And 3 pi 6 plus pi 6 gives us 4 pi 6. Which is 2 pi thirds, right? We can write that as 4 pi 6, or we can write that as 2 pi thirds. Pi is the same as 6 pi 6. So 6 pi 6 plus pi 6 gives us 7 pi 6. And then 3 pi halves is the same as 9 pi 6. So 9 pi 6 plus pi 6 gives us 10 pi 6. And 2 is the same as 12 pi 6 plus pi 6 gives us, oh, we need some space in there, 13 pi 6. I'm going to just try to move everybody up about a ½ an inch or so. Or maybe a little farther. There we go. That's enough for now. All right, so 13 pi 6. If you notice that look at the values in our table here and look at the phase shift values, they go up by 3 pi 6. And you might wonder, why 3 pi 6? Well, they go up by 3 pi 6 because our period is 2 pi, and that means our values change by 2 pi divided by 4, or pi halves. So since these values here, my base values here, are going up by pi halves, so are my values in my phase shift. That is another way that you can calculate it. You can look to see how my x's are going up by pi halves. You could just add pi halves each time, and you'd get the same number. All right, so let's get our y values. We do have new y values for the amplitude change. And then I'm going to graph the base graph as soon as we find our amplitude. Our base graph would be the period, the x after the period change, if any, and then y after the amplitude change, if any. And then we can translate. So I'm going to use this x. I'll use a different color. I'll use this x here and this y for the base graph, because my base graph is y equals -2 cosine x. And then after we translate it, will be instead of using this x, we're going to use this x, and we'll still use this y. For my translated graph is y equals -2 cosine x minus pi 6. Okay? I'll graph both. Most times you'll find it easier, though, to graph from your table than to try to count. Sometimes it's kind of hard to count, by in this case, by pi 6. All right, so in blue, let's find the amplitude change first, and then we'll graph. So our amplitude is the coefficient in front of cosine. So our amplitude is 2. Notice the negative means we also have a reflection. It will reflect over the x-axis. All right, so we can find our new y values simply by multiplying by -2. We can take care of the amplitude change and the reflection all in one. All right, so boy, these values have really gotten a little offline, haven't they? They're no longer matched with their right value. Well, that's a little closer anyway. All right, so, and let's move can't move these ones down, huh? They're all attached to one another. Well, it's okay, I guess, until down here. So I'll just rewrite another -2 and -2. That's a parentheses. All right, so 1 times -2 will give us -2. 0 times -2 is still 0. -1 times -2 is a +2. 0 times -2 is a big fat 0. 1 times -2 is -2. Okay, so now let's graph our base graph in blue, and then we'll graph our translation. So our base graph, our first value is 0, -2. Right, so right there. And then our next value would be pi halves 0. Right? And then our next value is pi 2. And then we have 3 pi halves 0. If you can, man, these values are really offline, aren't they? It is 3 pi halves 0. Maybe we should move that up so it's actually matched with the value there. So hopefully you can see okay and figure out where I am. But they just don't want to separate, do they? So 3 pi halves is right here, and going across there is 0. So 3 pi halves 0. And then finally we have 2 pi -2. So here's our base graph. There it goes, nice and smooth. And then, of course, we know that it's going to go back and just do the same thing over and over and over again. But that's one period of our base graph. All right, so now let's graph our translation here. So instead of using those old x values, we're going to use our x values from our phase shift, where we've added pi 6. So for my translated graph, we have pi 6 -2. So we've shifted over a little bit. And it would probably help if I put some other values in here. So I'm going to divide, since all of these go up by 6, I'm going to divide these things into thirds, and maybe that'll help me. All right, so actually I think 6 will probably even be better, because this is a half. If I divide each of these into thirds, right, would have 3 6 make a half. All right, so those are by 6 now. These are by 6. So, you can feel free to add some other values, or maybe when you make your graph, you'll go up by something other than pi halves. I'm kind of stuck with the graph I have up here right now. All right, so now our first point is going to be at pi 6 -2. So that would be right here. Our next point is at 4 pi 6 0. All right, so this is be 3 pi, so I'm going to move over one past the, oops, but let's put it on the right spot, 0, 4 pi 6 0. And then we have 7 pi 6, just 1/6 more than pi, and that's 7 pi 6 2. And then we have 10 pi 6, so 3 pi 6 is 9, so 1 more is 10. And we're at 0. And then finally, at 13 pi 6, 1/6 more, we're at -2. So right about right there, I guess. All right, so then here is our translated graph. Not too bad. I'm a little crooked right at the top. Don't know what happened to my graph there. Oh, that looks a little bit better. There we go. All right, so you can see that it's the same graph. It's just shifted a little bit to the right. It's shifted pi 6 to the right, actually. Let's give our domain and range here, and this graph is done. That took me longer than I thought it would. So -infinity to infinity is the domain, and the range -2 to 2 because of the amplitude change. Okay. So we have an amplitude change and we're reflected. Okay. All right, so let's go on. I'm going to do 2 more graphs. Here's our next one, and I have my grid all ready to go here. All right, so we have no vertical shift. We do have a period change and an amplitude change. Let's do the period change and the amplitude change. We'll graph our base graph, and then we'll do the phase shift, and we'll graph the translation. All right, so to find the period here, well, the very first thing we have to do is notice there's a coefficient with x, and it's in the parentheses. You want to factor out b. Very important. Okay? All right, so if I factor the b out, I have y equals -2. Oh, and by the way, b is 3. Cosine, and now 3 parentheses x plus pi thirds. You divide pi by 3, you get pi thirds. Okay? So to find my period, since b is 3, the period would just be 2 pi divided by b, or 2 pi divided by 3. So 2 pi thirds is our period. To find our key points, we just take 2 pi thirds divided by 4, because all the key points occur 1/4 of the way through the cycle, through the period. All right, so 2 pi thirds divided by 4 is the same as 2 pi thirds times 1/4. And that'll reduce. That's 2 pi over 12, which is pi 6. Hey, that was just like the one we had last time. So same phase shift, excuse me, not same phase shift, we're doing a period. So our period is the same as our phase shift last time. So pi 6 is the key points for the period. Nothing to do with the phase shift. I was just thinking about our last problem. So pi 6 is where all of our key points occur. So that means we're going to count by pi 6. The first value is going to be 0. It's still going to be the same starting point. The last value has to be the end of the period. So it has to be 2 pi thirds. Right? So if we're counting by pi 6 and don't end up at 2 pi thirds, we've made an error. Right? All right, so we're just going to count by pi 6. Easy enough. All right, so 0 plus pi 6 is pi 6. And pi 6 plus another pi 6 is 2 pi 6. And I'll just leave it like that for now. And add one more, and I got 3 pi 6. And, well, I'd want 4 pi 6 if I add one more 6. But 4 pi 6 is, of course, 2 pi thirds. So we ended up in the right spot. Okay, so we've got our new values from the period change. Let's get our new y values for the amplitude change, and then we'll graph that base graph, and then we'll take care of the translation. All right, so our amplitude is the coefficient in front. It is 2, and we're also reflected. We have a reflection over the x-axis because that value is negative. So let's take care of the amplitude change and the reflection together. We'll just multiply by -2. It's that easy. Easy peasy. Lemon squeezy. All right, so we have then -2, 0, 2, 0, -2. There's our values. Let's graph our base graph. No translation. Base graph is y equals -2 cosine 3x. Has the period change, has the amplitude change, but nothing else. All right, so I'm going to graph these points, my new x and my new y. And so we've got, and let's put some values on here. Let's see, we're going up by 6. We want to get to 2 pi thirds. So what if we go up by 6? Sounds like a good thing to do. All right, so I don't have to cram everything in here. This is pi thirds. I'll label every other. And pi thirds, well, I think that should be enough. And 2 pi thirds. I don't know. Once I get to the phase shift, I may think otherwise. Well, you know, I've got so much space up here. Let's just give myself more space. Let's do every 2 lines is pi 6 and see if that fits in. So pi 6, that makes this pi thirds. And then, because that would be 2 pi 6, which is pi thirds. And then I'd have 3 pi 6, which is the same as pi halves. And then I'd have 4 pi 6. And 4 pi 6 is the same as 2 pi thirds. Okay, so hopefully everyone's okay with that. So every one of these it's a 12th actually. I had enough space up here, so. And then these will just go up by 1. 1, negative 1. All right. So there we have our table, and that's what you'll do too. You'll label it by something that's going to work. I figured let's give myself more space just in case I need it for the translation. All right, so we'll graph it, this one in blue, I guess, since I wrote everything else in blue. Y equals negative 2 cosine 3x would be the points 0, negative 2, and right there. And then we have pi 6, 0, so that would be right here. And then 2 pi 6, which is the same as pi thirds, 2, so that's right there. And then 3 pi 6, which is the same as 1/2. I could actually just write that there. I have enough space, I think, to write in pi thirds and pi halves. And that would be at 0. And then 2 pi thirds, we're going to be at negative 2 again. All right, so here is our graph. Kind of stretched it out because I gave myself lots and lots of space. Whoops. Whoa, what happened there? I have to say my arm got in the way. Actually, not my arm, but my shadow. So I could not see where the graph was. Whoops. And now I just hit the board. Let's try this again. I'll try to get my shadow not to block it. All right, one more try. Maybe because it's so stretched out. See, every time I write on this side, my shadow from my arm gets in the way and I can't see. You don't have that problem when you're writing on paper. All right, so there's our base graph. There's y equals negative 2 cosine 3x. Let's find our phase shift. All right, so our phase shift, we're almost done here. I'll put it over here. Our phase shift is pi thirds. And it is to the left because it's positive. So pi thirds to the left, which means we're going to subtract pi thirds from all of our points here. Okay, so we're going to subtract pi thirds. So 0 minus pi thirds is negative pi thirds. And pi 6 minus pi thirds. Well, pi thirds is the same as 2 pi 6. So that's going to be a negative pi 6, right? And then pi thirds minus pi thirds, that's just 0. Pi halves, that's 3 pi 6, right? So 3 pi 6 minus 2 pi 6, because oops, that's the same as pi thirds, is going to give us a positive pi 6. And then 2 pi thirds minus pi thirds is just pi thirds. So same y values, but these are our x values for our translation. Our translated graph in green now is going to be y equals negative 2 cosine, and I'll take those out of the parentheses, oops, 3x plus pi thirds. All right, so we'll graph the points Negative pi third. Oh, you know, I should probably label the values a little bit over, huh? All right, so of course that's 0. And then this is, I hope I have enough space. I think so. Would be negative pi 6. And yeah, I have just enough space because that would, this one here would be negative 2 pi 6, which is the same as negative pi thirds. Just enough space. So negative pi thirds, negative 2. Well, I have enough space, but my writing is smack in the middle there. But hopefully you can see that okay. Then I have negative pi 6, 0. And then we have 0, 2. And then pi 6, 0. And finally, pi thirds, negative 2. And now all we have to do is connect our dots with a nice smooth curve. And there we are. There we have our translated cosine graph. All right, so it's just been moved pi thirds to the left, but it's the very same graph other than that from our base graph. Our domain, of course, is all real numbers, and the range negative 2 to 2 because of the amplitude change. Right? I think I have one more. Silly me, I thought I could do this in 20 minutes. I think it's going to take me 30. I do have one more, and this is the last one, and then we'll look at vertical shifts in the next podcast. All right, so this does not have a vertical shift, so I'm going to just cross this off. I do have an amplitude change, a period change, and a phase shift. Let's find the period and the amplitude, and then we'll take care of the phase shift. All right, so our B value here, let's factor this out. So we'll factor out B, and we have y equals 3/2 cosine 2x minus pi halves. If you don't remember to factor out B, your phase shift is going to be incorrect. So B here is 2. Okay, so I'll put a little reminder there to factor out B. Okay, and an exclamation point because it's important. So that means our period is 2 pi divided by 2. So that means our period is going to be pi. Our key points will therefore occur at pi divided by 4 because they're 1/4 the way. All right, so our new x values are going to be, we start at 0 and count by pi fourths. Pi fourths and 2 pi fourths, which is the same as 1/2, and 3 pi fourths and 4 pi fourths, which is just pi. Oops. Over here, I lost my pi. There we go. All right, so notice that our last value, our last key point, is the same as the period, and that would be correct. We have an amplitude change. Our amplitude is the coefficient in front of cosine. It's 3/2. So we'll just multiply all of these by 3/2. So 3/2 times 1 is 3/2. And 3/2 times 0 is 0. And 3/2 times -1 is a -3/2. And times 0 is still 0. And times 1 is 3/2. Not very difficult. Let's graph our base graph. So our base graph is y equals 3/2 cosine 2x. That's our base. And it's just the point, it's helpful if I put some numbers up here. I have pretty much space, and I'm going to go up, I'll just make these a fourth. I think that'll be okay. 1, 2, 3, 4, so this would be pi, and 1, 2, 3, 4, that would be 2 pi. I think a fourth will be fine. All right, so I'll put some values in between. That means this is pi halves, and this is 3 pi halves, and hopefully I'll like that when I'm all done. And this one will be 1 and -1, which makes this 2 and -2. All right, so we have the point 0, 3/2. So, right, halfway between 1 and 2. And then we have pi fourths 0. So, right there between 0 and pi halves. And then we have pi halves negative 3 halves. So that would be kind of right in the middle of my 2 there. And then we have 3 pi fourths 0. And the whole thing's done by pi. And there's 1. All right, so we'll graph our base graph. Boy, it's really hard to see that one point there. That's in the middle of the 2. There's our base graph. And now let's translate our base graph. We have a phase shift. Our phase shift is going to be pi halves. And it is to the right. So it will be a positive pi halves. We'll add to our new period values, or new x values. So we'll just add a half a pi. So instead of 0, we have pi halves. Instead of, I hope that's going to fit. I think it will. Instead of pi fourths, so pi fourths plus pi halves. Pi halves is 2 pi fourths. So 2 and 1 is 3 pi fourths. Pi halves plus pi halves is pi. 3 pi fourths plus pi halves. So pi halves is the same as 2 pi fourths. That's going to give us 3 plus 2, 5 pi fourths. And if you notice here, my values are going up by a fourth because that's how the values go up on the period. So the phase shift values are going to go up by the same amount. And then pi plus pi halves is 3 pi halves. So that'll all fit in there just fine. All right, so let's graph our translated graph, which is y equals 3 halves cosine 2x. Actually, I want to keep that 2 out of the parentheses. We took the time to factor it out. Let's leave it out. All right, so we're going to graph the point 0, net 0, after the phase shift. I'm going to put a little check mark right there and right there. All right. And I'm just going to double check. Yeah, we graphed the right x values when we graphed the base graph. Let's make sure we graph the right x values on the phase shift. All right, so pi halves, 3 halves. All right, so pi halves is right here, so we're going to be right there as our first value. And then we have 3 pi fourths 0, so right there would be 3 pi fourths. And then we have pi negative 3 halves, so right here. And then 5 pi fourths 0, so 5 pi fourths is just one more fourth. Each of these lines, by the way, is a fourth, and we'll be at 0. And then our last value is 3 pi halves, which is right there. We see it. And 3 halves, so right there. And there we are. There's our graph. It's just translated. Right? So I hope you're finding these things to be easy as pie, because they are. With a little work, you'll get it. All right, so our domain, negative infinity to infinity, and our range is a negative 3 halves because of the amplitude change. And that's it for me with phase shifts. Come and see me again for vertical shifts, okay? Bye-bye.